A few videos ago I made this. This is a PulseJet engine that creates thrust through reciprocating pulsated combustion. I don't know how to weld, so I made it using a 3D printed mold and carbon fiber. And guess what? It worked. I love it!
This video was brought to you by Keeps.
I was so happy about creating my first working PulseJet engine. It was pulsating, making noise, and generating power. It seemed unreal. And in fact, it was.
Shortly after my success, I measured the thrust the engine was producing and the result were a measly 400 grams.
Pathetic!
I tried making different designs, bigger designs and weirder designs, but nothing really seemed to work.
Every single engine I built was underperforming according to the plans. The plans. Of course! Finally, I understood the plans, and that is thanks to the suggestions you guys made on the comment section. And for that, I have to thank you. Okay, right now I'm gonna teach you guys a very simple trick that will enable me to increase the power of the engine without really doing much. In fact, it's such a simple trick that I don't know how it didn't occur to me before. Well, right here we have a propane-butane can that has a simple orange valve. If I open the valve a little bit, I can produce a small flame. Now, without even touching the valve, I can increase the outlet pressure simply by doing this. Cool, right? But what's happening here? As many of you guys might already know, it all comes down to in which state of matter the fuel reaches the engine. This kind of can has pressurized butane-propane gas that is in fact so compressed it's actually a liquid. If I open the valve in its normal position, the liquid has time to decompress and comes out as a gas. But if I turn the can upside down, the liquid has no time to decompress and comes out directly in that state. This helps with the engine performance because, by definition, a liquid has more matter in the same space than a gas, what practically translates to more fuel in the combustion chamber. Okay, let's see if the trick actually works. As you can see, the difference in power when I turn the can upside down is palpable, which is great news. But the fantastic thing about testing is that we discovered things we were not looking for.
The first thing that I discovered is that it's so much easier to start the engines when using a spark plug ignition system. When lighting up the engine with a torch, it can take me up to half an hour to get them going, but with the spark plug, it's first try, first run. The second thing I learned was that by keeping the compressed air pistol on the inlet, all the power that would be normally lost is redirected to the exhaust. Not only that, but the forced flow of air makes the explosions more efficient and powerful. I actually tested the difference it would produce in thrust, and as you can see, is pretty significant.
Now, flipping a can is pretty easy. For the spark plug ignition, I have Inspira. What I don't have is an onboard compressor. And surely I can't strap my compressor to the engine. What I need is a small device capable of generating a strong flow of air. I didn't know where to start, so I asked for the help of the compressed air master himself, Tom Stanton. And he said,
Bonjour, Inspira. I have the perfect solution for you.
Tom Stanton is not French, but I don't know how to do a British accent. Every time I try to do one, it goes Australian for some reason.
Croissant! Inspira, you should use an EDF, mon friend. It's like a very powerful fan. Just try it, you idiot petite Portuguese man.
Easy, Tom.
What are you complaining about? I'm not real Tom. I'm just an offensive version you created, you stupid baguette.
Yeah, that insult doesn't even make sense.
Oh yeah? Your videos don't make sense. Oh ho ho!
An EDF is an electric ducted fan, which means it's a fan powered by an electric motor inside a duct.
The name is pretty self-explanatory.
This kind of fan uses a brushless DC motor, which is a very powerful kind of motor. That is actually not a DC motor at all, but a variation of a three-phase motor created by Nikola Tesla. To simulate the three phases needed, it's used an ESC, or electric speed controller, and to power the motor is normally used a LiPo battery. As a way to regulate the speed, I used an Arduino and a potentiometer.
Okay, so I should be able to turn on using this switch. Okay, that sound means it's ready. And now I should be able to control the speed with the potentiometer. I think it's better to 3D print a support. I'll be right back. I'm back with some filament. Hoo-hoo! I need some wood. Oh, I got it. Oh. Okay. Wood. Wait a second. Haha! The third tomato! Let's see what the wind does to him. Yes! You dirty tomato! Feel the power! Oh, maybe some smoke! Oh, the smoke machine! Not ready yet. Sponsor time. 2 out of 3 men experience some form of male pattern baldness by the time they reach 35. And guess what? I'm one of the 2. I'm starting to look a lot like Vegeta, which is not necessarily a bad thing since he's my favorite character. But if I don't do something about it, I'll start to look less like Vegeta and more like Krillin. And let's be honest, nobody wants to look like Krillin. If that happens, all I can do is wear my plan B. But for now, I have a solid plan A, which is provided by this video's sponsor, Keeps. Keeps has revolutionized the way men are treated for hair loss. They make it easy and they deliver your medication every 3 months, so you can say goodbye to the long lines at the pharmacy and the awkward doctor visits. With Keeps treatment, you'll see actual results in 4 to 6 months, but you need to act now while you still have hair. The best part is that you don't need to go broke to get your hair back. Their subscription is completely affordable and FDA approved. If you are on Team Vegeta like myself and you want to do something about it, go to keeps.com/intexa to get 50% off your first order. By doing that, you're not just helping yourself, but also helping me do more videos like this. And for that I give you a big fat thank you. Back to the video.
As you can see, the EDF accelerates the air backwards, and the duct helps in straightening the flow in the right direction. This specific EDF is 64mm in diameter and can generate 540 grams of thrust. Because I can't really fit that on the inlet of the engine, I 3D printed a converging nozzle, and this happened. For some reason, the smoke is not getting sucked into the fan, but instead being deflected backwards. Of course, this has something to do with the constriction on the nozzle. So I did another simple test. I tried to fill the glove using the EDF.
Not able to feel it. I mean, it has enough strength to basically turn over the tomato, but it can't feel the glove. Why is that?
I was a little bit confused and had no idea why it was not working.
Intexa, this is bad karma for all the tomatoes you have tortured.
Well, if that's the case, it was totally worth it.
You idiot! You can't make the fan work, so now you'll get no fans working on the subscribe button.
That's a horrible play on words.
Oh yeah? And you're a terrible engineer. Nobody likes unsuccessful projects. Admit it, you're under pressure.
Under pressure. Under pressured. That's it!
The EDF is under pressured. It's not producing enough pressure, because they are designed to accelerate air and not to compress it. It's like throwing a tomato against a box. The tomato has speed and momentum, but it doesn't have any constant force. any obstacle can stop it and spend that momentum. In this case, what I need is a constant force. What I need is pressure.
To get that pressure, I can use a 100 years old invention called TurboCharged.
A turbocharger is a dynamic compressor that uses a rotating impeller and a volute casing to compress air and thus give it that extra punch that I need. 3D modeling a turbo compressor was not an easy task. Their geometries revolve a lot around spirals, so it's not that linear to model. For that reason, I'm leaving the files in the description of the video. After the model was done, I 3D printed the impeller using a very strong resin called Ceria Blue, because this little boy will be rotating very fast and needs to be tough. The casing I 3D printed in PLA, but then I thought, I can probably fit this in the resin 3D printer. And I could, so I did. The support for the motor I indeed 3D printed in 2K blue PLA. To power the turbocharger, I used a 1.2 kW brushless DC motor that can spin at 62,000 RPM, a 150 amperes ESC, and a 14.8 volts LiPo battery.
Okay, I'm gonna do a quick speed test to see if the impeller can handle the high speed. Let's do this.
So far, so good. Good. It works! Yes!
After all the basic tests were done, I moved on to the PulseJet. I chose the focused wave engine PulseJet because it only has one inlet. I 3D printed the support for the turbo and assembled it on the PulseJet. I also 3D printed two nozzles so I could link the turbo to the engine.
Time for the real test! Haha! Oh! Oh! Yeah! Woo! I love it! It worked at the first time! First time it worked! Fantastic. Oh my god. Let's try it again. What's happening? I think I broke this. Oh, it broke. Yeah. The potentiometer mixed signaled and basically accelerated the impeller until it exploded. Yep, complete destruction. I need to 3D print another one. And we are back! So I 3D printed two more impellers. I'm gonna mount one and I have this one as a backup. Now we'll proceed to another test. Let's do this. Ready? One. Stop it! Wow! That's a lot of snow. Jesus, it worked pretty well. Yeah! TurboCharged PulseJet! Domenica! So, this is happening. Yeah. The turbocharger is still working, but I think the spark plug got out because I didn't isolate it properly. So, I need to take care of that. Yeah, let's do that. I glued it again! Now we can proceed. Okay. You're ready to go! A slap for the audio! Why are the screws coming out? Because I don't know how to open threads, that's why. Yes, I'm gluing it down so you can't move. Easy boy! Really? I'm gonna glue you down too! Catherine, pass me the tube, please. Please, pass me the tube! I'm tired of this. If you need to be here, I'm gonna use wire. I think it's good. I think it's good. It is working. Okay, let's give it a go. There's too much pressure! The engine can't take it! I need to find a better way to glue it down. I guess. Oh, I have an idea! I have an idea! Let's try that. Turning on the ignition! Ignition! Oh my god, that's insanity! So much smoke! As you can see, the PulseJet engine and the turbocharger are a match made in heaven. And the engine does seem more powerful. But is it producing more thrust? Well, I tried to measure the thrust using a kitchen scale like I normally do. But the setup was too rudimentary. I can't keep everything in place. First, I need to build a better setup to measure the thrust. In the end, the turbocharged PulseJet engine as a concept worked. Now it's just a matter of optimizing. I'm aware not everyone watching my videos has a 3D printer at home to replicate these projects. And that's the reason why, on my last video I gave away a 3D printer to the most liked comments suggesting a theme for a future video. The winner was Tom Stanton, a small YouTube channel that just reached 1,000 subscribers. Congratulations, Tom! You can now do projects with 3D printed parts. Like, for example, a compressed air engine. Okay, I'm just joking. The actual winner was Daniel Matias, a fellow Portuguese that suggested that I could give a try at the Vortex 2. And here he is, standing next to his printer. If you also want to win a 3D printer, all you need to do is subscribe to the channel, leave a like on this video, and post a comment suggesting a theme for a future video. The most liked comment will receive a brand new 3D printer. Well, this is everything for today. I need to get back to work. Thank you for watching, and remember, tomatoes are disgusting. See ya!